Alright, this video is the most recent set of notes that we have writing and solving linear systems. It's the word problems. It's a green sheet that was in your folder. I'm going to do the four examples, and then you should have another worksheet to do for homework. So I'm going to start with example number 1. It says, Joey has a handful of dimes and quarters. There are 22 coins in all. The value of the coins is $3.55. How many dimes does he have, and how many quarters does he have? So you're going to notice in all of these that we have a very similar set. I always look at the question first and define what my two variables are going to be. So we've been solving systems with two variables just by procedure. Now these variables actually mean something. So in this case, the question says, how many dimes does he have? How many quarters does he have? So that means my x variable is going to represent the number of dimes I have, and the y variable could represent the number of quarters. You always want to define the variables first, and then we can start writing algebraic expressions to represent this. Rule of thumb is, if I have two unknowns, I need two equations in order to solve for them. So the first sentence that gives us information says, there are 22 coins in all. That means the sum of the number of dimes and quarters that he has is 22. So I have the two amounts put together is 22 in all. Okay, so however many dimes I have plus however many quarters I have must give me 22 coins. Okay, it says the value of the coins is $3.55. So now if x represents the number of dimes, I can determine how much money I have in dimes by taking the dollar amount of dimes times how many I have. So I could say I know that a dime is $0.10 times how many I have would give me how much money in dimes I have. And then if I add to that the dollar amount I have in quarters, that should add up to, in this case, $3.55. Now this particular problem has decimals, so it's okay that we work in decimals. At this point, we're going to decide whether we want to use substitution or elimination. I personally think that using substitution by solving this top equation for either x or y is the easiest route to go. So I'm going to solve it for y by taking away the x, so that I have y equals 22 minus x. Now I can take this and plug it into the second equation for y. So that gives me 0.10x plus 0.25 times the quantity of 22 minus x equals 3.55. So I need to carry this 0.25 through. Okay, so I didn't do anything with the 0.10x. 0.25 times 22 is 5.5. 0.25 times a negative 1x gives me a negative 0.25x, and I haven't done anything with a 3.55. So I see I have a 0.1 and a negative 0.25 that I can combine. Whoops. So now I've got negative 0.15x plus 5.5 is equal to 3.55. And I'm just continuing to solve from here. I'm going to take. So I solved for the x value, got my x equals 13 dimes, and then I plugged that back in and got my y equals 9 quarters. The big thing here is making sure that I include a unit, or what the variable and the value actually represents. Example number 2 says the number of calories in a mint is 3 times the number of calories in a stick of gum. There are 70 calories in 5 sticks of gum and 3 mints. How many calories are there in each stick of gum and each mint? Okay, so I look at the question first, and that allows me to define my variables. So it says how many calories are there in each stick of gum. So I'm going to say X then is number of calories in a stick of gum. And Y would be the number of calories in a mint. So then I go back to the information that's given to me. It says the number of calories. So I'm going to break that down. The number of calories in a mint. Okay, so that simply for us is Y. Okay, so the number of calories in a mint, Y, is 3 times the number of calories in a stick of gum. 3 times number of calories. So I've got 3 times number of calories in a stick of gum is X. Okay, there's that one. Then it says there are 70 calories in 5 sticks of gum and 3 mints. So 5 sticks of gum would be 5X and be plus 3 mints, and it says that that is 70 calories. So now I don't have to solve anything for a variable. It's already done for me, so I'm going to plug in 3x where I see y in the other equation. So I've got 5x plus 3 times 3x equals 70. So continuing to simplify, I've got 5x plus 9x equals 70. So that's 14x equals 70. And I get x equals 5. Now, again, 5 what? X, we said, represents the number of calories in a stick of gum. So there's 5 calories in a stick of gum. Okay, then going back, it said y is equal to 3x, so I'm going to y equals 3 times 5, and I get 15 calories in a mint. All right, example number 3. A group of friends go out for lunch. If 2 order hot dogs and 4 order hamburgers, the bill will be $23.50. If 5 have hot dogs and only 1 has a hamburger, the bill will be $18.25. What is the cost of a hot dog or a hamburger? So I'm going to define my variables as cost of a hot dog. We know that that's going to be in dollars. And y being the cost of a hamburger, also in dollars. So the first sentence says 2 order hot dogs, 2 order hot dogs, and 4 order hamburgers. The bill is $23.50. If 5 have hot dogs and only 1 have a hamburger, I have a bill of $18.25. So now again, you decide whether you're going to solve using elimination or substitution. I personally see that this y here is easy to solve for, which would give me 18.25 minus 5x, and I can plug that back into the first equation for y. So that gives me 2x plus 4 times the quantity 18.25 minus 5x is equal to $23.50. So if I carry that 4 through, I'm going to get 2x plus 4 times 18.25, 73, minus 20x is equal to 23.50. So that's negative 18x plus 73. And I'm going to solve for x. So 23.5 minus 73. So I've got negative 18x is equal to negative 49.50. Divide by negative 18. And I get x equals 2.75, and that is dollars per hot dog. And then y then we said y was equal to 18.25 minus 5x. I've got 18.25 minus 5 times $2.75. And that gives me $4.50 per hamburger. Last but not least, we have example 4. The larger of two numbers is 9 more than twice the smaller. The sum of the numbers is 3 less than 5 times the smaller. What are the numbers? So I'm going to call the numbers x and y. So I'm just going to call it number 1, and it's going to be, we'll say, the smaller one. And number 2, the larger. Okay, so the first one says the larger, that's our y value, is 9 more than twice the smaller. So if something is 9 more, I'm going to add 5 or add 9 to it. Twice the smaller. So twice the smaller is 2x, and then it says it's 9 more. The sum of the numbers, the sum, adding them together, is 3 less than 5 times the smaller. So if something is 3 less, I'm going to take that value and subtract 3. And that's 3 less than 5 times the smaller. So it's already solved for y in the first one, so I'm going to plug that in down here. So I've got x plus 2x plus 9 is equal to 5x minus 3. So that's 3x plus 9 on the left side, 5x minus 3 on the right side. And I'm going to start solving, getting the x's on the same side. And then add the 3, so I've got 12 equals 2x. Divide by 2, and I get x equals 6. So my first number is 6. We said y was equal to 2x plus 9. So that's 2 times 6 plus 9. 12 plus 9 is 22. So my two numbers are 6 and, 21.